Okay, the next two congruence postulates are ASA congruence and AAS congruence. That is angle, side angle, or angle, side congruence. The major difference there is where your side is located. If I have two congruent corresponding angle pairs and one congruent corresponding side pair, the major thing to look at is that side your included side or not? Meaning, is that the side that touches both angles, or is it not? If it touches both angles, it's included, it's in between your angles, we'd use angle-side angle congruence. If it doesn't connect your two angles, then it's not included, it's not between them, we'd use angle-angle-side congruence. Okay. How that might look. If I have triangle ABC and I have triangle DEF, knowing I have two pairs of congruent angles, angle A is congruent to angle D, so I'll call it angle A congruent to angle D, and angle B is congruent to angle E. Angle B is congruent to angle E. What I'm going to do is show you that I can just copy this picture over. So copy it and paste it right over to here. I'm doing the same two angles. The side matters now though, because if I use side AB congruent to side DE, that's my included side. Segment AB congruent to segment DE. That side is in between, it's included. Now my triangles are congruent. My triangle ABC is congruent to triangle A and D match up, B and E match up, which means C and F match up. Because I have two angles and the included side of one triangle congruent to two angles and the included side of another. That's what allows me to prove my triangles are congruent. The difference being over here, it would not be my included side of segment AB. It would be something like segment BC congruent to segment EF. That side is not touching angle A, but it touches angle B. This touches angle E. B and E are congruent, so I know these are corresponding sides. I would say that segment BC is congruent to segment EF, which also makes my triangles congruent. So my triangle ABC is still congruent to triangle DEF, but when I'm writing my proof, I now have a different reason. So my general statement would be this, or my specific statement would be this triangle congruence, but I would have to say that they are congruent by angle-angle side, not by angle-side angle. That's the major difference between angle-angle side and angle-side angle. Now, let's get some practice looking at different figures and being able to decide what triangles are congruent and why. So, in this first example, and it says up here, don't forget, we can always mark reflexive property, that's a congruence, and we can always mark vertical angles, that's a congruence. Those are the only two things we can ever look at a picture and assume. So in angle 1, the triangle on the left and the triangle on the right share a side. That's the reflexive property. I can mark that congruent. Now, what I do sometimes is I will just either cross off one triangle or just go off to the side and draw just one of my triangles and mark everything that I have marked. This is going to help me decide, do I have enough to prove the triangle's congruent? And if so, which method? Because we have side-side-side congruence, side-angle-side congruence, angle-side-angle congruence, or angle-angle-side congruence. Those are the four methods that we've learned so far. And when I look here, this is where I have to know the difference between angles and sides. That's a side, that's an angle, that's a side, that's an angle, that's a side, and that's an angle. My congruences are a side, and a side. So now I know my triangles are congruent by side, side, side congruence, because in one triangle I have 3 sides marked congruent to the corresponding ones on my second triangle. If you don't understand that, go back, rewind, and watch that part again to help you understand it a little bit better. In number 2, I can include that my vertical angles here are congruent. I'm going to give them a different mark than what these angles are marked because there's a different congruence here. So again, I have to decide, and I have space on the right, so I'm just going to draw the triangle on the right. On that triangle I have this bottom angle marked, I have this angle marked as congruent, and this side. So when I go through and I look, here's an angle, here's a side, here's an angle, here's a side, here's an angle, here's a side, my congruences now are an angle, another angle, and this side. So the question is, 2 angles and 1 side, 2 angles and 1 side. I'd have to choose between angle, side, angle, or angle, angle, side. That decision is made based on whether the side is in between the angles or not. Does it touch both angles? In this case it does. That is my included side. So now I would be able to conclude my triangles congruent by angle, side, angle congruence. Okay. Go ahead and press pause and try numbers 3 and 4. Take a look at them, mark any reflexive or vertical angles, decide if they're congruent or not, and then what method. When you're done, unpause to check your answers. In number 3, I have to add the reflexive property. They share this side. Because that's a right angle, we should know that this is a right angle. That's a linear pair. Then I have in my one triangle a side, an angle, and a side. The angle is the included side. That makes this congruent by side angle side congruence. In number 4, I also add the reflexive property. If I don't draw this triangle out separately and see that it's an angle, a side, and an angle with my included side, it'd be hard to see that those 2 triangles are congruent. And it'll get even more complicated in a problem like that when I ask you to actually name the congruent triangles, which we will get to. Okay, do the same thing for numbers 5 and 6. Press pause, try to come up with your answers, unpause to check. Okay, so we have 2 interesting circumstances here. In number 5, the triangles are congruent. I include my vertical angles being congruent, and then I can see that I have 2 angles and a side. But in this case, the side that I have is this side does not touch that vertical angle. That means it's not an included side. So my side doesn't go in between my angles. It's not angle, side, angle like we had in number 4. This one's going to be angle, angle, side. Number 6 is a different case. There's not enough information here. Because remember, it's side, side, side. I don't have 3 sides. I have a side, and an angle. And that's not enough information. We cannot prove triangles congruent with the angle not being the included angle. In order for this to work, I would have needed to know something about this angle here. This one that's formed by my 2 sides. Since I don't, I have not enough information to prove these triangles are congruent. Okay, we have one more triangle congruence to learn about. On the 3rd video, you guys can go ahead and learn about the HL congruence postulate.